And we're back. Now we will be focusing on weathering, the first part of our exogenous process. So weathering is defined as the disintegration and decomposition of rocks in situ. No transportation involved. So when we say in situ, it's within the site itself. So you may recall from our soil module that soil actually come from rocks. So once rocks are subjected to different geomorphic agents due and undergo weathering, they will produce this loose material, and that's called the regolith. So the regolith is almost microscopic materials that came from the rock itself. So regolith is again different from soil because soil contains biological matter. So regolith, which is from the rock itself, will become soil once biological materials are mixed in. Okay, so just to clarify that cycle, you have your rocks, which will undergo weathering, will produce regolith or the loose material, and then that loose material will be mixed in with biological materials, creating soil. So weathering is actually very important because life on Earth depends on plants, and plants depend on soil, which came from weathering process. Okay, so there are different types of weathering that we will be discussing later, but ultimately, weathering happens in the weakest part or starts in the weakest part of the rocks. So when there are microscopic spaces, cracks, joints, faults, fractures, lava vesicles, and other rock cavities, weathering will happen once geomorphic agents enter those small cracks and joints, like our example earlier in our introduction, then weathering will occur. Okay, so there are different types of weathering. We have three. So first, you have your physical or mechanical weathering. Second is your chemical weathering. And then finally, biological. So when we say physical or mechanical weathering, this is the disintegration of decay of rocks via weather elements. So subjecting landscapes into extreme or different changes in weather, temperatures, then involving freeze-thaw cycles, as our example earlier, that will create or will start the weathering process. Okay, so there is no change in chemical composition of the rock. So I would like to highlight this. Even if we are physically breaking the rock itself, the minerals which compose the rock still stays the same. Okay, another example of a physical type of weathering is your exfoliation. So exfoliation occurs when buried rocks are uplifted and exposed. Okay, so here in this picture, you will see the exfoliation sheets of Sierra Nevada. So you will see that there are sloping slabs of rock, but it looks like layer by layer, these rocks are actually weathering away, breaking from the rock itself. So what's causing that? So like in our previous example, water is responsible for this weathering scenario. So the exfoliation sheets in Sierra Nevada, although the rock itself looks very sturdy, the rock itself contains clay materials. And what happens is water reacts with that clay materials. And as you know, when water mixes with clay, it becomes this very soft and like mud-like material. So it softens the rock, which eventually causes the breakage of the rock pieces. So that's called exfoliation. Okay, so frost wedging is the formal term for our example earlier. The freeze-thaw cycles that we have discussed, where water comes into the crevice and then expanding when it freezes, that's called frost wedging. So again, frost wedging is an example of physical weathering. Another type of physical weathering is your salt wedging. It's quite similar because instead of the simply water entering the rocks itself, it's now salt. So you will often see this in coastal areas. So you will see that the rock itself has several holes. So very Junjo Ito-esque. But what happens here is salt. So salt enters the rock because of the salt water. So eventually the salt will deposit into the rock itself. And as more water comes in, the salt will attract more salt. So it will actually grow in the rock itself. The salt will expand and grow and grow. So not expanding, it will grow because it keeps interacting with salt water, and the water keeps drying, wedging in the salt some more, and then the rock itself will be broken down because of excessive salt, which is already within the rock pores. So that's an example of salt wedging. So you may not see here in this picture that there is salt, but you may imagine that there used to be salt particles here, which created the holes in the rock surface. Right. So all of these are still physical weathering because we did not change the composition or the mineral composition of the rock itself. We just broke it into smaller pieces. Okay, so next we have your chemical weathering. So when we say chemical weathering, this is the breakdown of rock due to chemical mechanisms. So quite interesting. Chemical weathering decomposes rocks through a chemical change in its minerals. So I would like to contrast this. Physical weathering is just the breakage, physical breakage of the rock itself into smaller pieces, while with chemical weathering, you are breaking the rock. However, you are also changing the minerals which is within the rock. Okay, so first example, oxidation. So rust is a result of the oxidation process. So rocks which is rich in iron may interact with water. Okay, so you may have already known this, that you shouldn't expose iron objects or metallic objects to water because it will eventually rust. So the water has H2O. So that's the chemical formula. So the oxygen in the water will react with the iron, thus creating that oxidation reaction, and the byproduct is the rust. Next, you have your hydrolysis. So you have, which is common in igneous rocks. So igneous rocks, which are high in silica, will react with water as well. And then you have your carbonation and solution. So carbon dioxide dissolved in water, okay, so reacts with carbonate rocks to create a soluble product called calcium bicarbonate. So this is one of the dangers of acid rain. So acid rain is dangerous not only for the plants and animals and the environment, but also to the human structures that we build. So carbon dioxide, if there is a high concentration of carbon dioxide in the atmosphere, once it starts to rain, it creates acid rain because you have this combination of carbon dioxide and water already, which will react with the human structures. Okay, so here in this picture, you will see that it's used to be a tombstone, but you cannot even tell anymore what has been written in this tombstone because of the carbonation and solution reaction. So it's the same thing that is happening here whenever there are cave systems. So cave systems has always been a result of water interacting with rocks. So water dissolves the carbonate. Okay. There. So water dissolves the carbonate in the rocks itself there, and then creating this large cave systems. Okay. It can also cause different sinkholes to happen. This is an extreme scenario though. So this is an extreme scenario, but ultimately water interacting with the rock underneath will eventually break it down, and then it will create sinkholes, cave systems, and so forth. Okay, so here you also have your feldspar, which undergoes hydrolysis. So in this scenario, the feldspar will now disintegrate into clay because of the interaction with water. Okay. Then finally, we have our third type of weathering, which is biological. So it may not be obvious, but plants creates a large role in the weathering process. So they may be like unharmful or they don't pose much threat, but they do change a lot in the landscape, especially if it like they are sequoia trees. So in this picture, you will see that some trees may grow really really big. I think not necessarily even this big. You might have seen mango trees pulling up concrete sidewalks, roots breaking our concrete slabs because they have that ability. So they may not pose so much risk, but they can change a lot in our landscape. Okay. And finally, biological not only involves plants, it also involves animals and human beings. So human beings have changed a lot in our landscape. So this example is the biggest coal mine on our planet. I think this is somewhere in Africa. So you can just see how much have already changed in this landscape because of human activity. Okay, so that's actually it for our weathering process. I think the video is already long, so we'll stop here and then we'll continue with mass wasting in the next video.